Hello everyone, welcome to my channel Concept in Chemistry. In the previous two videos we have discussed about the mole concept. In this video we are going to discuss some Q&A, that is question and answer regarding mole concept. So let's move on to the first question, that is question number 1. It is calculate the volume of 66 gram CO2 at NTP. How can you calculate the volume of 66 gram CO2 at NTP? We know, what we know that 1 mole CO2 has volume 22.4 liter at NTP. We know this one. Okay. Again, we can calculate 1 mole CO2 is equal to 44 gram CO2. This is the molecular weight of carbon dioxide or gram molecular weight of carbon dioxide, and we have seen in the previous videos that 1 mole of something is equals to its gram molecular weight. So carbon dioxide has gram molecular weight 44. CO2, it has, so molecular weight of CO2 equals to the atomic weight of carbon plus 2 into atomic weight of oxygen, that is 16, and it is equal to 44. So gram molecular weight of carbon dioxide is 44 gram. Okay, so we can write 44 gram CO2 has 22.4 liter volume at NTP. So the question is the volume, what is the volume of 66 gram CO2? So 66 gram CO2 has volume 22.4 into 66 by 44 liter at NTP, and it is equals to 33.6 liter at NTP. So this is the answer, 33.6 liter. Okay. Let's move on to the next question. Question number 2. It is given as calculate the weight of 5 mole O2 gas. Calculate the weight of 5 mole O2 gas. Okay. First, calculate the molecular weight of O2. What is the molecular weight of O2? That is equal to 2 into atomic weight of oxygen, that is 32. Again, we know 1 mole O2 is equal to its gram molecular weight equals to 32 gram O2. Therefore, the 5 mole O2 is equal to 5 into 32 gram O2 equals to 160 gram. So this is the answer, that this is the weight of 5 mole oxygen gas. We know 1 mole oxygen gas has weight 32 gram. So 5 mole has 5 into 32, that is equals to 160. So this is very simple question. Go on to the next question. Question number 3 is calculate the weight of 12.046 into 10 to the power 25 numbers of NH3 molecules. how can we calculate the weight of these numbers of NH3 molecule? Again, first we have to calculate the molecular weight of ammonia. What is the molecular weight of ammonia? It is equal to atomic weight of nitrogen, that is equals to 14 plus 3 into atomic weight of hydrogen, that is equal to 17. Okay, so first we have to calculate the molecular weight of ammonia. What is the molecular weight of ammonia? This is equals to the atomic weight of nitrogen, that is equals to 14, and 3 multiplied by atomic weight of hydrogen, that is equals to 1, and that becomes 17. Okay, so we know that 1 mole NH3 has 6.023 into 10 to the power 23 numbers of NH3 molecules, right? This is the Avogadro number. Okay, so we know 1 mole ammonia has 6.023 into 10 to the power 23 numbers of ammonia molecules. Again, we know 1 mole ammonia is equal to 17 gram ammonia, because we know 1 mole ammonia is equal to its gram molecular weight, that is 17 gram. So we can write 17 gram ammonia has 6.023 into 10 to the power 23 numbers of NH3 molecules. Or we can write it in reverse direction as 6.023 into 10 to the power 23 numbers of NH3 molecules have weight equals to 17 gram. Then our question is the weight of this number of ammonia molecules. So the 12.046 into 10 to the power 25 numbers of NH3 molecules have weight equals to 17 into 12.046 into 10 to the power 25 divided by 6.023 into 10 to the power 23, and that becomes equals to 3400 gram of ammonia. So this is our answer. So these numbers of NH3 molecule has weight 3400 gram of ammonia. Moving on to the next question. The next question is, it's a little bit tricky question. Calculate the number of hydrogen atoms and oxygen atoms in 0.09 gram water. So we have to calculate the number of hydrogen atoms and number of oxygen atoms in 0.09 gram of water. First, it is well known that in one H2O molecule, it has 2 hydrogen atoms and 1 oxygen atom. So if we can determine the number of water molecules in 0.09 gram of water, then we can also determine the number of hydrogen atom and number of oxygen atom in this amount of water using this relation, right? So first, calculate the molecular weight of water, and that is equals to 2 into 1 plus 16, that is 18. We know 1 mole H2O has 6.023 into 10 to the power 23 numbers of H2O molecules. Again, we know 1 mole water, that is equals to its gram molecular weight, that is 18 gram. So we can write 18 gram water has 6.023 into 10 to the power 23 numbers of water molecules. Or from here we can calculate the number of molecules of the number of water molecules in 0.09 gram of water. So 0.09 gram of water has 6.023 into 10 to the power 23 into 0.09 divided by 18 number of H2O molecules. Again, we know in one H2O molecule there is 2 hydrogen atom and 1 oxygen atom. So number of hydrogen atom becomes equals to 2 into this 6.023 into 10 to the power 23 into 0.09 divided by 18, and that is equals to 6.023 into 10 to the power 21. So this is the number of, because this is the number of water molecules, and we know in one water molecule there is 2 hydrogen atom and 1 oxygen atom. That's why we multiplied this total term with 2. We multiply this total term with 2 to get the number of hydrogen atom in 0.09 gram of water. We can also calculate the number of oxygen atoms. So number of oxygen atoms equals to 1 into 6.023 into 10 to the power 23 into 0.09 divided by 18, because in one water molecule there is 1 oxygen atom, and hence the number of oxygen atoms become 3.0115 into 10 to the power 20 3.0115 into 10 to the power 27. So this is little bit tricky. We have to think it in always in this way, using this relation. We have to always think the mole concept problems using this relation. So this is the main relation to calculate the given property. Okay. Moving on to the next question. This is the last question. Calculate the charge of 1 mole electron. This is very easy question. This is very easy. Again, what I say, the relation 1 mole equals to 6.023 into 10 to the power 23 numbers. It is the basic relation. This relation can also be applied here. So we know 1 mole electron equals to 6.023 into 10 to the power 23 numbers of electrons. This is the basic relation or basic formula. Again, we know the charge of 1 electron equals to 1.6 into 10 to the power minus 19 coulomb. So this is the charge of 1 electron, and in 1 mole electron there is 6.023 into 10 to the power 23 numbers of electrons. Therefore charge in 1 mole electron becomes equals to 1.6 into 10 to the minus 9. This is the charge of 1 electron into multiplied by the number of electrons in 1 mole, that is equals to 6.023 into 10 to the power 23. Hence the charge becomes 96368 coulomb. So that's it for today. So these are some questions regarding mole concept. if you want to get this question and answer in soft copy or hard copy, it is given in the lecture note part 2. The link is given in the description. Please go through it. Thank you. That's it.